In this video, you will learn how to write a one-dimensional loop experiment in QCoDeS. In order to do so, we have to start our Jupyter notebook first, like I did here. I already called it one-dimensional loop experiment. And then we start by importing all the different functions and features and libraries that we need. So we start by importing QCoDeS as QC. The next thing that we will need are our instruments. In my case, I don't have any instruments connected to my computer, but for the sake of this tutorial, I will just use a dummy instrument. So we import, from QCoDES .tests .instrument mocks import dummy instrument. This one. Oh, no, we want a dummy instrument. The next thing that we will need are our parameters. So from QCoDES instrument parameter import parameter class. Another parameter that we want to measure during our experiments is the elapsed time. In order to do so, there's a special parameter which we also have to import. So we go to we use from QCoDES .instrument. We use the specialized parameters, and in this case, the one which we use for the elapsed time. Another thing that we of course also need if we want to measure with a loop is the loop function. The loop function we simply find by going to QCoDES.loops, and then we use the class loop. Okay, so this is basically our setup and everything that we need to import. After having now imported all of the different packages and the different classes, we can now start by defining our instruments. In my case, as I already said, I would like to use a dummy instrument. So I start by defining my instrument as source1 src1 equals, and then I take the dummy instrument class, put a name, and in this case I could also skip the name tag and just put a string instead of that. So I save a little bit of time, but I don't do that. In this case I call it source1, and then I also have to define the gates of that dummy instrument, which you probably don't have to do in your case, but you would rather just define the address of your actual instrument. In my case I just define an instrument with 2 gates, but we won't need both of these later on. Okay, so the next thing that I have to do is I have to define my parameters. Parameters are basically the important ingredients for plotting later on, and usually the different parameters are already defined in the instruments, but sometimes it makes sense to design your own parameters, maybe if you want to introduce lambda functions, or in my case, for example, I also have to define the time parameter, which I take from the specialized parameters that I imported over here. So let's start by defining that particular time parameter. I will call it t, and this is then just the elapsed time parameter, and I give it the name t. The next parameter that I want to define is my applied voltage. So let's just assume I would have a voltage source and I could measure the current in my system, and I would like to measure a test resistor for this particular case. So with my loop function, I want to measure the current that is being produced by applying a certain voltage. And then I want to ramp that voltage and see how the current is behaving. I would expect to see a linear IV curve, and this is what we are going to do right now. So now I'm able to apply, I want to define that applied voltage parameter. So I will define a parameter, and in this time I don't use the name tag like over here, but I just put the name immediately, which is v in my case. Then I also have to give it a label, which will later on be used for plotting, and I call that v applied. And then I also have to give it a unit, which is also very important for plotting because every parameter also always has to have a unit. Then I define a get function, which I say is the source .v1.get. It is .get. It is very important that in this case here I'm defining a function and not just a value. So if I would do, for instance, this, then I would just get the actual value. So this is getting me a value. The same is true if I do this. Then I would also just get a value, but I have to define a function here. This is why I don't put the brackets behind, so that we are actually left with a function. The same holds true for the set command. So I have to set cmd equals to source1.v1.set. And then I have to close because of the parameter bracket from here. So now I have defined a parameter which I'm able to get and to set. So I have a get command over here and a set command over here. Instead of that parameter, I could have also just used v1 because v1 is actually doing exactly that. However, I decided not to do that because it's nicer for the labels later on to have this one, and it's maybe also more clear for documentation. Now I need to define the current that I want to measure, and in this case this is just a fictional one, and that's also why I'm not going to simulate anything here, but I'm rather hard coding a certain resistance into my current. You shouldn't do that in the experiment though. So I start by defining a name for that parameter again. So I call that the current which is being measured. Then I just copy what I already used before. So I just copy that parameter stuff here. But instead of a voltage, I'm measuring a current now. And I'm also not applying a voltage, but I have a measured current. And then of course the units is also in amps. Okay. So now we have to define a get and a set function. Of course, we want to measure a current here, so we probably don't have to define a set function because this is a pure measurement parameter. So we delete this. Okay, so how can we get the get command now? Well, pretty simple. I just take the command that I had before and I divide it by 1000. And then I basically have a parameter, right? Well, if I do that, I will get an error. And the reason for this is that the output type in my particular case right here is not anymore a function. Because here, this one is a function, and now I try to divide the function by an integer value. And this, of course, won't work. So how can I solve that problem? Well, first of all, I can start off by using a lambda function. So I say lambda equals this. This means that basically the value that is being output here is treated by Python as a function. So Python thinks that this whole thing is a function. Everything that I put behind a lambda is always considered to be a function. So I change the object type of my output here from a value, which would be this divided by 1000. So if I did this, then I would just get a value. And now instead of doing that, I put the lambda before, and that makes it actually a function. So it looks like a function. And instead of the get, I can just do v1 and then open close bracket, which is basically the same. Okay, but this is now formally right, but it will still give me a problem. And that's why I have to also convert it to a float value. So I put the brackets like this, and then it shouldn't get me any problems anymore. Okay, so now that I have defined all my different parameters, the next step is that I actually have to write my loop, because I want to measure something, and that means I have to write a loop. Okay, so how does it work? First of all, I have to set my parameters. And in this case, that means that I have to put everything into an initial state. In the experiment, you would, for example, start by ramping your voltage to a certain value where you want to start. and initialize your whole setup. In this case, I don't have to initialize the voltage because it's anyways just a fictional thing, but of course, since I have the time parameter, I also have to reset the time in my setup. So I start by resetting this time value to 0, so that at the beginning of my experiment, the t value equals 0. The next thing is that I have to define a loop. So I define a loop as a loop, and this is now the object, the class loop, and I define an object. So this is the class loop which initializes an object over here. And what are the parameters that I have to give that loop? Well, I have to tell it what to sweep and in which parameter space to sweep it. So we want to sweep the voltage. So in this case, I want to sweep my parameter V applied, and I want to sweep it from -1 volt to 1 volt at a stepping of 0.01. Okay, so this is the first thing that I can do. The second parameter that I can define in the loop, which is also very useful, is the so-called delay. The delay is basically the time that your loop is waiting until it goes to the next value. So it's kind of a delay time. This is also in seconds, so I will put this on, let's say, 1.001 seconds. And now, since I have a parameter which I'm sweeping, I have to define a parameter which I'm actually measuring. And in this case, I want to measure for each of these values, well, the two different things. So first of all, I want to measure the applied voltage, this one, which I'm just applying. So it will use this get command. So it will use the set command to apply, and then later on the get command for the measurement over here. Then I want to measure the current. And finally, I also want to measure the time. Okay, now I start this and nothing happens. Well, why is nothing happening? That's because I have to start the loop. So in order to start the loop, I just say loop.run and press then enter, and now it starts. So you can see it started. Then it tells us the data set which it's measuring, so it's 201 points for all these different values, and then finally it's finishing. Also notice that up here it tells us the set points, which is reset in that case, and then here we have the measured values which refer to the names of the values, not the names that are set here in Python. That's very important later on when you try to analyze your data. And of course, you can also see if I change these parameters over here, for example, like that, then it takes also a little bit longer for the loop to run. That's just because the delay time is a little bit decreased. Another important thing that you should also see over here is, let's just assume I want to run this whole code once again. Then I have to be a little bit careful because this instrument is already defined, and QCoDeS makes sure that I don't define any instrument twice, so I don't override anything during measurements. That means if I write that particular part, if I run that particular part here once again, then I will get an error because there is already an instrument that has the same name. In order to avoid this error, for example, if you want to test, to play around a little bit with that, you can just say you want to restart the kernel over here, and then if you do the same thing again, it won't throw you an error anymore. Okay, with that, I think I showed you how to run a loop. In the next step, we will learn how to plot the data from our loop in QCoDeS.